So we're in Unit 3. In Unit 3, we're going to break this up and we're going to do 3 lessons, and then we're going to have a quiz, and then we're going to finish up 2 or 3 lessons, and then we'll have a test over Unit 3. So Unit 3, our cadence is going to be a quiz about middle of the way through and a test at the end, okay? So we have a dance party coming up on Thursday because we're going to be learning the way functions look. So we have a parent function dance party in here. So there are certain functions that they're dance moves that go with them. So it'll improve your social life on the weekend if you have these. This is me being sarcastic. Anyway, so there are different functions we have to memorize. If you look in 3.3, the dance moves are there and they look pretty bad. So you got an old white guy teaching you dance moves. So it's not probably going to be something that you want to emulate there. so does Michael have the moves? So I don't know. We will go through that. But before we get to the dance party, we got to do a couple of things before we get there. Okay. So we're studying functions in this unit, and we'll be doing that in sort of Unit 3, 4, and 5. We're doing different kinds of functions. Pretty much the rest of this term we'll be doing different kinds of functions. But we need to talk about certain properties of functions. Okay. So the first thing we're going to talk about today, we're talking about a function being even or odd. Okay, you know what it means for numbers to be even or odd, but what does it mean for a function to be even or odd? So first of all, let's talk about what it means for a function to be even. Okay, we will say that a function is even if it is symmetrical about the y-axis. Okay, so if I look at this graph, this is the what axis over here. This is x, and then this is y. What does it mean to say it is symmetrical about the y-axis? Use your English words. What does it mean to be symmetrical? It's the same. Another word would be, it would be a what kind of image? A reflection, a mirror image, okay? So if I look at this particular graph, if I were to draw a line right here where the y-axis is, okay, does this graph look identical on the right and the left? Yes, this is an even function, okay? So we will say that this function is even, okay? Because it is symmetric about the y-axis. The way you can tell that graphically is what you see on the right and what you see on the left, they reflect each other perfectly, okay? Now, let's take a look at another example. Got this graph right here, so that'll give you part of a graph. I'm saying, what would it take to complete this function so that it is symmetrical, okay? So if it's symmetrical, what does it have to look like on the right? Yeah, it's going to have to look exactly the same as it did over here on the left. So it looks like it goes through the point, what is this point here, about, so 1, 2, a little bit past 2 when it gets up to, so somewhere about right here, right there, and it comes back down, so at 2, so it's going to need to come back down here at 2. So it's going to need to do something like this. That's what it's going to take for this to be an even function. What you see on the left and right are exact mirror images of each other, okay? I'm going to calibrate the board before I do the next one here. Okay, this function looks a little bit different because it's in a couple of pieces, okay? But how would I make this to where this would be an even function, okay? So if I look at this point right here, this is on the which axis is it on? Yeah, so do I have to go somewhere to find a point that matches it? It's that same point, okay? So, and if I look at this, if I go over 1, 2, I get to this point. Where do I have to go to find its matching point from here? 2 to this point, okay? So if I had a dot right there, and then if I did what with these 2 dots? If I connected these 2 dots, right there, and right there, that gives me that part. So that gives me this part, and then what do I do about this one here? If I look at it, I go 1, 2, and I get what kind of circle? Open circle. So if I were to come over this way and put an open circle, okay, and then if I go over here, 1, 2, 3, 4 to get a closed circle, 1, 2, 3, 4 to get a closed circle, then what will I do with those 2 points? Yeah, connect those 2 points, okay. Now you see that this is an even function, okay? So this one might look a little bit more complicated, but all you have to do is just whatever you're given, okay? You just have to match it, okay? So when I look at this point right here, I had to go 2 to the left. Well, I got to have a matching point 2 to the right in order to make that work, okay? Now, let's look at a couple of examples here below and just ask, is this an even function? Yeah, this function is even. My indication is when I look at what I see on the left and what I see on the right, it matches. What about this function? No, this function is not even. Not necessarily, okay? So functions can be even, odd, or neither, and we'll get to that. So what about this function here? Is this an even function? Yeah, this one is not. This function is not even, because this point here, I would need it to be a reflection. It's not an exact reflection. What about this one here? This one even or not? No. Now, if this point were moved where? If this were moved back to the y-axis, then yes. But when I look at the y-axis, what I see to the left of this axis, what I see on the left and the right do not match each other exactly. So this one is not even. What about the next one here, graph C? Yeah, this one is even, okay? And you could see that this graph, if I just moved this one to the left, that's probably what happened here. When I look at the y-axis here, I see identical pieces on both sides of the axis, okay? So graphically, that's what it means for a function to be even. Now, what I typically keep in mind with even functions is, so if you look at it, you got a point here. You got some x value here, okay? And you get some negative x value over here. When I plug in x, I get some kind of number. When I plug in negative x, what number do I get? So here's a value of x. When I plug in x, I get some point on the graph, okay? What do I expect to get when I plug in negative x? The what? Any special point. What is it? No? So here, I plug in x, and I get whatever this number is. I plug in negative x, what am I going to get? The same number, okay? That's what it means for a function to be even. When you look at your x value and your negative x and you plug them in, you're going to get the same value. So even means it looks the same on both sides. So what we need to realize is that when a function is even, I look at it and it's symmetrical about the y-axis. Now what we'll spend time when I see you on Wednesday is talking about algebraically what it means for a function to be even. But a function is even if this condition holds. If f of x and f of negative x are equal to each other. All this means is every function that I looked at that was even, so let's go back to this one example here. So at this point, this function is what? This is negative, this is the point negative 2, 7. If that point is negative 2, 7, I can guarantee you this point right here is 2, 7. Okay, that's what it means for a function to be even. You know, this point right here is going to be what? 1, this is the point 2, 0. If this is even, this has to be what? Negative 2, 0. Okay. So if you've got even functions, when you look at a positive value for x, you look at the negative value, you're going to get the same y values. So what this means is that if a function is even, f of x and f of negative x have to be equal. Even means you get the same value for both values of x. Now, you guys take a look at the next one. Okay, so I want you to work on this one. So in this one, the way to make a function even is just look at whatever value I have here. This is the value at 7, and that's 4. I don't even have to know those numbers. Know that this is negative 7, 4. So this point right here, if this is 7, 4, this has to be negative 7, 4. That's what it means for a function to be even. Whatever value I see in the x-axis, if I see the negative of that, I'm going to get the same y value. Let's look at the graph of a function. We're going to deal a lot more with graphs of function that comes out later. I want to graph f of x equal x squared. So what happens when I square 0? 0. Negative 1 squared, 1. 1 squared is 1. Negative 2 squared, 4. And 2 squared is 4. So if I graph these points, 0, 0, 1, 1, 2, 4, and negative 1, 1, negative 2, 4, this graph should look familiar to you. The graph of a parabola. Is this an even function? Yes, this function is even. I can tell graphically that it's even because it looks like a mirror image on either side of the y-axis, okay? And I can also look and see f of negative 1 is 1 and f of 1 is 1. F of negative 2 is 4 and f of 2 is 4. So that's also telling me that it's even because I'm getting the same numbers, okay? So yes, this is an even function. Okay, I can look at the graph and tell, and then I can also look and see if you plug in a 5 here, when you square 5, you get 25. Plug in a negative 5, square negative 5, you get 25. So you're getting the same values. For every positive value, the corresponding negative value gives you back the same answer. So that's what makes a function even, when you get the same values. Now, let's talk about what it means for a function to be odd, okay? Even means the same values. Odd, think of odd means the opposite, okay? So a function is said to be odd if it is symmetric about the origin. Another way of thinking of it is whatever happens on one side of the y-axis, it does the opposite on the other side of the y-axis. So think about this function. If we look at this function, it goes from the origin, it goes up, it goes down. What would be the opposite of going up and then going down? Going down, then going up. So what you can see is this is symmetrical about the origin. So here, if I go over, it looks like I go over negative 1 and up 1.5. This looks like I go to the right 1 and down whatever 1.5 or close to that number. So it does the opposite thing, okay? So for a function to be odd, it does the opposite thing on both sides of the y-axis, okay? So it is symmetric about the origin, meaning whatever you do on one side of the origin, go up and down, you do the opposite over here. You go down and up, okay? So it's symmetrical about the origin. So let's take a look at an example, and let's make this function an odd function, okay? Now, what would it do to make this an even function? What would I do? Yeah, I would just mirror this and just go straight up like that, okay? To make it an odd function, I can't do the same thing. I have to do the opposite thing. So it looks like this. It looks like it goes, this is what this function does. It goes flat and then it goes up. It looks like it goes flat and then it goes up. So the opposite of that would mean it goes flat in this direction and then it goes down. That's what would make this an odd function. So it does the very opposite thing on the other side of the axis. So you guys try one, the next one. So what I want you to do is make this an odd function. And you should get something that looks like this graph here, okay? So to make a function odd, you just do the opposite. So the way I look at it, there were 3 points here that I needed to graph this shape. This was to the right 6. Well, the odd point will be to the left 6. This point is up 6. Well, this point is down 6. This point is right 4, up 6. This is left 4, down 6. Okay, so you just do the opposite to create an odd function. So, even function. When you look at an even function, it's symmetric about the what? Y-axis. Okay, that means when you look at the function and the y-axis, describe what you see on both sides. It looks the what? It looks the same, okay? An odd function is symmetric about the origin, okay? What that means is when you look at the function on one side of the graph, what does it look like on the other side of the y-axis? It looks the very opposite and not the same, okay? So what's happening algebraically, we'll talk about this. If a function is even, f of x and f of negative x are equal to each other. So even means the same. If a function is odd, f of x and f of negative x are what to each other? They're opposites to each other. So that's why I'll have f of x is negative f of x is equal to negative f of negative x. Okay, we'll talk more about that later. So let's don't get hung up, but let's do a graphic example of that, and then I should be able to turn you loose here quickly. Let's look at x cubed. What is 0 cubed? 0. Negative 1 cubed. Negative 1. 1 cubed. 1. Negative 2 cubed. Negative 8. 2 cubed is 8. So if I were to graph this, this goes through 0, 0, 1, 1, 2, 8, negative 1, negative 1, negative 2, negative 8. So this function looks like something like this. So this is an odd function. What you see here is going up on this side, then it's going down on the other. So it's very opposite. So if I plug in f of negative 1, I get negative 1. If this were even, I could plug in f of 1, and what would I expect it? I would expect these numbers to be what? If this were even, I expect these numbers to be what? The same, okay? But they're not the same. They're opposites of each other. That makes this a what? Odd function. So for this one, I would expect if this were an even function, those numbers would match exactly. They don't match exactly. They are opposites of each other. That makes this an odd function. So in this case, is this an odd function? Answer is yes. This is an odd function because what you see on one side of the axis, you see the exact opposite on the other side of the axis. Now, let's look at these functions here. So look at the first graph. Tell me, is this an even function or an odd function? This is even. How do you know it's even? It's identical on both sides of the y-axis, okay? Now, if the point 2, 0 is on this graph, which is right here, what other point do I know has to be there? Yeah, negative 2, 0 has to be there for this to be an even function, okay? If the point 1, 1.8 is on this graph, so 1, 1.8 is right there, what other point has to be there? Yeah, negative 1, 1.8 has to be on that graph. Otherwise, it's not an even function. So it's an even function, meaning if this point is on the graph, when I take the opposite x value, I got to get the same y value, okay? Let's look at the next graph here. This is what kind of function? Even or odd? This one is odd because I see the opposite thing going on. So if 1, 0 is on this graph, what else has to be on this graph? Negative 1. What's the opposite of 0? Yeah, there is no opposite. Plus, so negative 1, 0 has to be on this graph. If positive 0.42 and negative 3, so 0.42, negative 3 is on this graph, what other number has to be there? Negative 0.42, positive 3, okay? Remember, even means same, odd means opposite. So 0.42, negative 3, that's going to be this point right here. If 0.42, negative 3 is on this graph, then negative 0.42, positive 3 has to be on this graph, okay? So with even, you get the same y values. With odd, you'll get the opposite values. So if I've got this point, xy, is on my graph, if this function is even, then what point has to be there? Negative x what? If xy is on the graph, if it's even, what point has to be there? Negative x, y. Okay, so f of negative x has to be y. Okay, if the function is odd, xy is on it, what point has to be there? Negative x what? Negative y. So I get that. Then f of x is negative y. So I get the opposite value. So let's look at an example of this. Here's a point on the graph. If this function is even, what other point has to be there? Negative 1, 6, okay? If it's odd, what has to be there? Yeah, -1, -6, okay? If this point is on the graph, what has to be there when it's even? Yeah, 1, -6. If it's odd, what has to be there? 1, 6, okay? So all I'm doing is saying, if this point is on the graph, take the negative of the x value. If it's even, you get the same y value. If it's odd, you get the opposite. So for 3, -4, what's there for even? Yeah, -3, -4. For odd, it's -3, 4. Okay. For a negative b, if it's even, what has to be there? Negative a and negative b, right? If it's odd, what has to be there? Negative a, positive b, okay? If I've got pi square root of 3, what has to be there if it's even? Yeah, negative pi square root of 3. If it's odd, what has to be there? Negative pi, negative square root of 3, okay? So all I'm figuring out, if this point is on a graph, if it's even, when I take the opposite x value, I get the same y value. If it's odd, when I take the opposite x value, I get the opposite y value, okay? So we'll get more into that when we get into tomorrow's lesson. So you guys answer these questions right here. So I've got several examples of that where I give you a point. See if you can get this straight. Are we doing okay with that? You guys ahead of me? Okay. So I won't hammer this. If you had questions about that, let me know. I won't go over that, but I think you've got that. So you should be able, at the end of this lesson, look at a graph and tell me if it's even or odd. If I give you a point on the graph, then you need to be able to give me back the corresponding point if it's even or odd. If I give you half of a graph and say complete it to make it even and complete it to make it odd, you should be able to do that. You should know that even functions are symmetric about the y-axis. Odd functions are symmetric about the origin. The way I think of it, even means the same. It looks the same on both sides of the axis. Odd means opposite. It looks the opposite on both sides of the axis, okay? Now, what we'll do when I get together on Wednesday, we'll talk about how to prove something is even odd without the graph, just doing the algebra, which most people find a little bit tougher. But make sure you're grounded in what the graph looks like for even and odd, and being able to know, if a point is on the graph, what point has to be there to make it even and what point has to be there to make it odd, okay?